Basic networking concepts. In this chapter you will learn basic networking concepts such as the basics of network communication, device addresses, basic networking protocols, networking devices. Basics of network communication. Data communications refers to the transmission of digital data between two or more computers and a computer network or data network. The physical connection between networked computing devices is established using either cable media or wireless media. Network communication works very differently than communication between a peripheral and a computing device. When your computer sends a print job to a printer connected to a USB port, the connection is direct between the two devices and is a single stream of information. Network communication between two devices is more complicated. The information must be turned into small bits, packets, which may be sent via different paths, and must be reassembled at the destination in the correct order. Basics of packet transmission. Everything a user does on the internet involves packets. Every web page that a user receives comes as a series of packets, as well as every email a user sends out is sent out as a series of packets. Networks that ship data around in small packets are called packet-switched networks. Another way to visualize this is to think of yourself ordering a dining room table set of a website. On the website, you see an image of the complete dining room set, table and chairs. When the vendor prepares to ship you the table, the vendor has to break down the table and chairs and wrap them up in their own boxes along with a set of instructions on how to reassemble the unit. Once that is complete, the vendor attaches a shipping label with your home address to each box, or one label for the entire pallet, to be delivered to your home. Once the boxes, or pallet, arrives at your home, you must open each box and begin the process of assembling the table and chairs as per the instructions given so that you can have the dining room set in your house that you saw on the vendor's website. When information is sent over a network connection, the information is divided into packets. Assume that a file can be divided into 100 packets. All of the packets need to contain the origin and destination information. To prevent the information from becoming corrupted along the way, all of the packets need to contain error-checking information. Because the packets need to be reassembled at their destination, each packet needs information to identify where it belongs in the finished product, packet 01, packet 02, etc. As the packets flow through the network, devices known as routers determine which packets stay in the network, which ones are routed to their destination, and the best route to follow. The destination information in the packets enable the routers to determine where the packets are going. As the packets travel, they are intermingled with many other packets going to many other destinations. When the packets reach the destination, the information contained in each packet enables the destination device to reassemble the information in correct order so it can be acted upon, to send a web page, download a file, etc. The response is packetized and sent back to the requesting device in a similar fashion. DNS, Domain Name System. The Domain Name System, DNS, is the phonebook of the Internet. Humans access information online through domain names, like Facebook.com or YouTube.com. Web browsers interact through Internet Protocol, IP, addresses. DNS translates domain names to IP addresses so browsers can load Internet resources. When you enter the name of a website or click a link to a particular web page, the technical name for what you have typed or clicked is a Uniform Resource Locator, URL. DNS works by translating a URL into the actual IP address used by that resource. The DNS is the name for the network of servers on the Internet that translates domain names, such as www.google.com and individual host names into their matching IP addresses. If you manually configure an IP address, you typically provide the IP addresses of one or more DNS servers as part of the configuration process. DNS uses port 53. URL to IP translation. DNS relies on special servers located across the Internet known as DNS servers. Each Internet Service Provider, ISP, provides the IP addresses of one or more, typically two, DNS name servers to the devices that connect it. DNS name servers, often called simply DNS servers, receive information about websites and the IP addresses matching them, and they use this information to translate URLs into IP addresses. When an IP address is provided and its URL is translated, that's an example of a reverse DNS lookup. LAN versus WAN. A local area network, LAN, is a computer network within a small geographical area such as a home, school, computer laboratory, office building or group of buildings. A LAN is composed of interconnected workstations and personal computers which are each capable of accessing and sharing data and devices, such as printers, scanners and data storage devices, anywhere on the LAN. LANs are characterized by higher communication and data transfer rates and the lack of any need for leased communication lines. A wide area network, WAN, is a network that exists over a large-scale geographical area. A WAN connects different smaller networks, including LANs and metro area networks, MANs. This ensures that computers and users in one location can communicate with computers and users in other locations. WAN implementation can be done either with the help of the public transmission system or a private network. The Internet is an example of a WAN. Device addresses. There are two ways a networked device can distinguish itself from another device on a network. By having an Internet Protocol, IP, address. By having a Media Access Control, MAC, address. IP addresses. An IP address is a unique address that identifies a device on the Internet or local network. It allows a system to be recognized by other systems connected via the Internet Protocol, IP. The type of networking that is used for WANs such as the Internet is called Transmission Control Protocol Internet Protocol, TCP/IP. TCP/IP networking is also used for LANs, even those that usually do not connect to the Internet. Every device on a TCP/IP network is identified by a unique IP address. There are two versions of IP addresses. IPv4 uses a 32-bit address composed of 4 numbers ranging from 0 to 255, x, 192.168.1.154. If any part of an IP address has a value greater than 255, it is not a valid IP address. X, 256.0.300.12 is not a valid IP address. A local loopback IPv4 address, 127.0.0.1 is assigned to each computer and is used only for testing. IPv6 uses a 128-bit address composed of 8 groups of hexadecimal numbers, some of which can be zeros, x, 2602, 0445, 0000, 0000, a 93E, 5CA7, 81E2, 5F9D or 2602, 0445, a 93E, 5CA7, 81E2, 5F9D, the characters represent 2 or more groups of zeros. The local loopback IPv6 address is 1. IPv4 supports up to 232 IP addresses, over 4.2 billion, that are visible to all devices. Due to the massive number of networked devices in the world, computers, tablets, smartphones, printers, etc., there simply are not enough IPv4 addresses to meet this demand. IPv4 addresses are available in two forms, public and private. Public IP addresses are assigned to servers on the Internet and to ISPs. Private IP addresses, usually start with 192.168, are assigned to networks that connect to the Internet using a router, such as small office or home office, SOHO, networks. A feature known as Network Address Translation, NAT, included in routers, enables a public IP address to provide access to multiple private IP addresses on a network. Any device that has an IP address is referred to as a host. IPv4 addresses are divided into Class A, Class B, and Class C categories. Class A range from 0.0.0.0 to 127.0.0.0, supports 16.777,216 hosts each on 128 networks for a total of over 2.1 billion addresses. Class B range from 128.0.0.0 to 191.255.0.0, supports 65,536 hosts on each of 16,384 networks for a total of over 1 billion addresses. Class C, range from 192.0.1.1 to 223.255.254.254, supports 256 hosts on each of 2 million networks for a total of over 536 million addresses. The remainder of the 4.2 billion available IP addresses are set aside for classes D and E, which are not used for normal IP addressing. IPv6 network address format is much different than the IPv4 format. It contains 8 sets of 4 hexadecimal digits and uses colons to separate each block. IPv6, because it uses a much larger address size, 2128, is capable of handling over 340 undecillion or 3.4x 1038 addresses, meaning there should never be a shortage of IP addresses anytime soon. IPv6 is replacing IPv4 networking, but the process will take some time, so for now, a feature called tunneling is required which enables IPv4 addresses to work over an IPv6 network. Regardless of if a device has an IPv4 or IPv6 address, or both, the IP address is assigned by a device called a Dynamic Host Configuration Protocol, DHCP, server on a network. The DHCP server may be built into the router or a separate device on larger networks. A device that is connected to different networks through the course of a day will receive a different IP address as it connects to different networks. If a device that is normally assigned an IP address by a DHCP server cannot connect to the DHCP server, it assigns itself an automatic private IP addressing protocol, APIPA, address. These addresses are randomly assigned from the range 169.254.1.0 through 169.254.254.255. Devices that use an APIPA address can connect to each other on a LAN but cannot connect to other networks or to the internet until the DHCP server starts working again. MAC address. A media access control, MAC, address, aka a physical address, is a hardware identification number that uniquely identifies each device on a network. The MAC address is manufactured into every network card, such as an Ethernet card or Wi-Fi card, and therefore cannot be changed. Every device that is network capable has a unique MAC address composed of 6 groups of 2-character hexadecimal numbers, 0 to 9, AF. The numbers may be displayed in groups of 2 or a string of values. MAC addresses may be written in uppercase or lowercase characters. The MAC address is assigned by the device manufacturer and is used to determine which device or devices will receive data. Network adapters have the MAC address on a label. You can determine the MAC address by using the network utilities covered in the previous section. A device that can connect to 2 different networks at the same time, such as a router, will have 2 different MAC addresses, one for each connection. Some operating systems and utilities allow the MAC address for a network device to be changed. This is referred to as MAC spoofing. Basic protocols. A protocol is a standard set of rules that allow electronic devices to communicate with each other. These rules include what type of data may be transmitted, what commands are used to send and receive data, and how data transfers are confirmed. The key network protocols you must understand for the IT Fundamentals certification exam are listed below along with their TCP port numbers. TCP port numbers are used to direct different types of network traffic. HTTPS. HTTP stands for Hypertext Transfer Protocol. HTTPS stands for Hypertext Transfer Protocol Secured. HTTP is the underlying protocol used by the World Wide Web, and this protocol defines how messages are formatted and transmitted, and what actions web servers and browsers should take in response to various commands. Hypertext refers to the hyperlinks contained in many web pages. These links can be clicked to request information from another server. A website such as http://www.thiswebsite.com makes an unencrypted connection, while https://www.thiswebsite.com is a secure connection, encrypted connection. Originally, secure connections were used mainly for electronic banking or shopping. However, many websites now are requiring secure connections to protect users and websites from attack. A normal connection, HTTP, uses TCP port 80 and a secure connection, HTTPS, uses TCP port 443. Secure connections also display a padlock icon next to the website address. POP3. POP3, Post Office Protocol 3, is the third version of a widespread method of receiving email. Similar to the physical version of a post office clerk, POP3 receives and holds email for an individual until they pick it up. All versions of POP work by checking an email server and downloading new messages to your email client app. For users who have only one computer, POP3 works well. However, for users who switch between computers, POP3 and earlier versions have a major limitation. If you retrieve email on a desktop computer and on a laptop, each computer will have only some of the messages unless you configure your email server to keep a copy of your email. When the server keeps a copy of downloaded email, you might download the same messages over and over again. Email systems that utilize POP3 servers to retrieve email typically use SMTP to send email. POP3 uses TCP port 110. Many email systems now use the IMAP protocol instead. IMAP, Internet Message Access Protocol, IMAP, is an Internet standard protocol used by email clients to retrieve email messages from a mail server over a TCP/IP connection. Instead of downloading new messages to the user's computer, IMAP displays messages when received and enables the user to keep them on the server and organize them in folders. If a user checks for email using IMAP on multiple devices, all devices can show all of the user's email. A user can delete IMAP messages whenever necessary. Multiple users can check a single email box at the same time. When configuring a new email service, the user must select the protocol to use. Some services support only one protocol, whereas others allow you to choose between IMAP and POP3. IMAP 4 is the current version of IMAP. IMAP uses TCP port 143. SMTP, Simple Mail Transfer Protocol, SMTP, is a protocol for sending email messages between servers. Most email systems that send email over the internet use SMTP to send messages from one server to another. The messages can then be retrieved with an email client using either POP or IMAP. In addition, SMTP is generally used to send messages from a mail client to a mail server. SMTP uses TCP port 25. When configuring email settings on a client, you need to know the server type, S, used, SMTP, POP3, or IMAP, the ports used. Default values may be changed by some ISPs, the username and password for the email service, and the security settings. Check with the ISP or organization that provides internet access for the correct values. Security layers you will encounter include SSL and TLS. Secure Socket Layer, SSL, is an encryption technology used by secured, HTTPS, websites. To access a secured website, the web browser must support the same encryption level used by the secured website, normally 128-bit encryption, and the same version, S, of SSL used by the website, normally SSL version 2.0 or 3.0. Sites secured with SSL display a padlock beside the browser's URL and often a green address bar if secured by a certificate. Transport Layer Security, TLS, is the successor to SSL. SSL 3 was somewhat of a prototype to TLS and was not fully standardized. TLS was ratified by the ETIF in 1999. However, many people and companies might still refer to it as SSL. Networking devices. Networking requires hardware devices as well as software. The software needed for networking is built into both desktop, laptop, and mobile operating systems. Network adapters are also built into these devices or can be added by connecting an adapter to a USB port. However, other devices are needed to make a connection to a network. Modem. A modem, modulate-demodulate, is a hardware device that converts data into a format suitable for a transmission medium so that it can be transmitted from one computer to another. Modems were originally created for the process of changing digital signals into analog signals sent over telephone lines to a remote computer. Modem now refers to any device used to connect a computer or network to the internet. Router. A router is a networking device that forwards data packets between computer networks. Routers perform the traffic directing functions on the internet. Data sent through the internet, such as a web page or email, is in the form of data packets. A packet is typically forwarded from one router to another router through the networks that constitute an internetwork, i.e. the internet, until it reaches its destination. A router has at least two network connections that use RJ45 cables. The port labeled WAN connects the router to a modem. The port labeled LAN connects the router to a switch. If the router has a built-in switch, it has multiple LAN ports numbered starting at 1. Most routers today are wireless routers that combine a router, a switch, and an access point. A router has two IP addresses because it has two network connections. One network connection uses a private IP address and is used to attach to the LAN ports numbered 1 to 4 or higher. The other network connection is the one used to connect to the internet via a modem. This is a public IP address. Switch. A switch is a high-speed device that receives incoming data packets and redirects them to their destination on a local area network, LAN. Essentially, switches are the traffic cops of a simple local area network. A switch enables direct connections between any two computers or devices on a network. Switches are available with as few as 4 or 5 RJ45 ports or with dozens of ports. Switches can be connected to each other so that a small network can grow without needing to replace existing switches. Most switches support at least fast Ethernet, 100 Mbps, signaling, with Gigabit Ethernet, 1000 Mbps, becoming common in home and small office networking. 10G Ethernet switches, 10 Gbps, are now used in enterprise networks. A managed switch can organize its switch ports into several logical networks that cannot interfere with each other. A managed switch enables different companies or departments to have independent networks in the same location. To enable a switched network to connect to the internet, connect a switch to a router. Many routers made for home or small offices include a multiport switch and a wireless access point. Access point. A wireless access point, AP, is a networking hardware device that allows other Wi-Fi devices to connect to a wired network. The AP usually connects to a router, via a wired network, as a standalone device, but it can also be an integral component of the router itself. To connect a wireless network to a wired network, connect the RJ45 port on the AP to a switch on a wired network. If the wired network is connected to a router with internet access, the wireless network will also have internet access. As previously mentioned, a wireless router combines a router with an Ethernet switch and an AP. Firewall. A firewall is a network security system that monitors and controls incoming and outgoing network traffic based on predetermined security rules. A firewall typically establishes a barrier between a trusted internal network and untested external network, such as the internet. Firewalls can be either software or hardware. Firewalls are frequently incorporated into wireless routers, Microsoft Windows and Mac OS. Software firewalls are also known as host firewalls. Firewalls work like this: a computer from outside the network attempts to gain access to the email server on the network. The network has a firewall. Because no computer on the network has sent a request to the outside computer, the firewall blocks the incoming traffic from that computer. A computer on the network sends a request to a remote server hosting a website. The remote server sends the answer back to the computer on the network. Because the remote server is responding to a request from the network, the firewall permits the incoming traffic.